let's take a look at the three different temperature scales. All right, so we have Fahrenheit, which is the one that we are used to using for the US system. There's Celsius, which is what we use in the lab, and there is Kelvin, which is what the international system uses. So there's a few differences between these. The biggest differences exist between Fahrenheit and Celsius. So if we look at the freezing point of water compared to the boiling point of water, okay, on the Fahrenheit scale, there's 180 degrees to go between freezing point and boiling point. On the Celsius scale, there's only 100 degrees to go between the freezing point and the boiling point, which means there's 180 Fahrenheit degrees for every 100 Celsius degrees. The freezing points are also different. The freezing point of water in Fahrenheit is 32 degrees, and for Celsius, it is 0 degrees. So there's a degree size difference and a freezing point difference. When we go over to Kelvin, we will see that the freezing point of water to the boiling point of water is also 100. The difference between Celsius and Kelvin is just an additive scale because the freezing point of water is 273 on Kelvin and 373 for boiling. There are no negative temperatures in Kelvin. Kelvin is an absolute scale, and so that's where we get the additive difference in. Absolute 0 on Kelvin means the cessation of all movement of anything. Anytime something's even vibrating a teeny tiny bit, there is heat that's being generated. So as long as an atom has protons or neutrons that are vibrating in place or electrons bouncing around, it's going to generate an infinitesimal small amount of heat. So we have some equations we can use to convert between these. Okay, so if I want Fahrenheit and I have Celsius, I'm going to take my Celsius temperature, multiply that by 1.8, and then add 32. What I'm doing is I am fixing the size of the degree, and then I am adjusting for the freezing point. Because remember, there's 180 degrees Fahrenheit for every 100 degrees Celsius. If I take 180 over 100, I get that 1.8. Okay, and so sometimes you might see this written as 9/5. There's some schools that teach it with a fraction with 9/5. 9/5 is just the 1.8. Okay, so we have fixing the degree and then resetting the 0 point. If I'm going from Fahrenheit over to Celsius, I do the same thing. I just do it in reverse. First, I have to fix the freezing point, so I do the subtraction of 32, and then I divide by 1.8. And then Kelvin is easy. I'm going to take my Celsius and I'm going to add to it 273.15. Okay, so let's practice a couple of these. Okay. You set your thermostat at 72. What is that in Celsius? Okay, so in order to go between Fahrenheit to Celsius, first we subtract 32, and then we divide by the 1.8. So I can take my 72 degrees Fahrenheit minus 32 divided by 1.8. Okay, and I'm going to get 22.2 degrees Celsius. Okay, that's the whole thing. You're just plugging it into the equation and spitting it out. Okay, let's do a couple more practices. Let's do a Kelvin and a Celsius over to Fahrenheit. So we have somebody who experienced extreme hypothermia, temperature dropped to 20.6 Celsius. What is that in Kelvin? Okay, so to go to Kelvin, we're going to take our 20.6 degrees Celsius and add to that 273.15, and we're going to get 293.8 Kelvin. Okay, now I want to see Fahrenheit. So Fahrenheit, first we're going to multiply by the 1.8 and then we're going to add 32. Okay, so we're going to take our 20.6 times 1.8 plus 32. We're going to get 69.1 degrees Fahrenheit. Very cold person. Okay, definitely extreme low temperature there. All right, so that is our temperature conversion. There will be another temperature conversion slide in the extra practice at the end of the chapter for you to try your hands at.